Okay guys, in this video we're going to look at another hypothesis test. So this is example number 4 in the 10.1, 10.2, 10.4 guided notes packet, again found on the Canvas website. You'll need your calculator, your formula sheet, which can also be found on the Canvas site, and of course again the guided notes. So in this example, this is a little different. Excuse me. So this one says, has temperature changed since industrialization? Suppose that the mean temperature throughout history is 50 degrees Fahrenheit. Over the last 123 years, the temperature has been 49 degrees Fahrenheit with standard deviation of 5 degrees Fahrenheit. Can we conclude that the temperature has changed since industrialization? Use alpha is 0.05. Okay, so again, we have to be able to tell whether or not this is a hypothesis test, and so we've got another clue here with us being told that alpha is 0.05. And one of the questions then becomes is, okay, well, since we're looking at a hypothesis test, is it dealing with means or proportions? Because after all, the first step in this process is to establish our hypotheses. Okay, well, I think they give us a dead giveaway here, right? The mean temperature. So very clear that it's dealing with means. So this is going to be mu. So now the question is, what temperature are we dealing with as to be considered the parameter, right? And so it says, suppose that the mean temperature through history is 50 degrees Fahrenheit. Then it says over the last 123 years, the temperature has been 49 degrees. So a couple of things to notice here. So if it says over the last 123 years, guys, that's a sample, right? So n in this case is going to be the 123, and the x bar, or the sample mean, is the 49 degrees. Okay, now I want you to look at the sentence above it. It says, suppose that the mean temperatures throughout history, that's a parameter. So the hypotheses have to be dealing with 50 degrees Fahrenheit. And maybe I should use proper units. There we go. Okay, now we have to make a decision of which inequality to use. So it says, can we conclude that the temperature has changed? Okay, well, how does temperature change? Well, it can go up or down. And so we think that it's changed, so that means that it's not 50 degrees. And so that means that the null has to be equal to. So again, we can't say definitively that it's more than 50 degrees. We may have suspicions. We can't say definitively that it's less than 50 degrees. We have suspicions. It's changed in some way, and so that change means a not equal to. So that means that this hypothesis is actually two-tailed. Okay, so there'll be something we have to remember when we actually go and compute the, and go find the p-value in a minute. Okay, with that out of the way, we can now look at step 2, which deals with two-tailed. And so in this case, we're going to be dealing with the test statistic. Okay, so in this case, we're going to be looking for the probability, and in this one, we want the sample, x bar, is what? Well, something related to 49 degrees Fahrenheit. Remember, that's coming from the sample. And so now the question is it greater than, is it less than, what? We're not sure because the alternative has not equal to. Well, the clue is in what I told you before, is that this is a two-tailed test, right? So if I were to draw that normal distribution, we're looking at the area in the tails. And since we're dealing with area in the tails, and we know that the distribution is symmetric, what this tells me is that I can take x bar to be less than 49, and if we have to multiply it by 2. And what that's going to do is it's going to give us both areas in the tails. So once again, because this is two-tailed test, we want area in the tails, okay? And we have that if we find the area that's located here, that's going to be less than, right? And that's how our chart reads. So we can take the x bar to be less than 49. And since I want both areas and it's symmetrical, we have to multiply by 2. So it's easy to remember, two-tailed test multiplied by 2. Okay, now we have to convert this using Chapter 7 material. Fortunately, if you remember back in chapter 7, this one is a little bit nicer to deal with than the one we did with proportions. This one is very simply x bar minus mu over sigma over root n. So a little easier, I think, to compute. Okay, so let's see, we have 49 minus 50. And sigma here, did they give us sigma? They did. I think I overlooked that. So it says with standard deviation of 5 degrees Fahrenheit. Okay, so that's going to be 5 over the square root. And n we said was 123. Okay, so again, you might want to pause the video for a second and run the computation and see if it matches what I'm going to have. So this will be 2 times the probability that z is what? Less than negative 2.22. So you should have something reasonably close here. Okay, now let me pause for just a second because I would just want to reiterate that the test statistic here is negative 2.22. Okay, so if somebody asks on an exam, for example, or the homework, what's the value of the test statistic is negative 2.22. Okay, so it's important to have that distinction in the vocabulary. Now what this is going to lead us to is actually the third step, which is to find the p-value. Okay, so to get the p-value, what we're going to do is we have to go to the normal distribution table. And so you should be looking up negative 2.22 on your normal distribution table. So you might want to pause the video and take a look at that and then come back. Okay, and what you should have is 0.0132, if I can write. Okay, and this gives us 0.0264, and again, that is your p-value. Okay, now step 4 is we have to run the comparison between the p-value versus the level of alpha. So we have 0.0264 compared to alpha, which is 0.05, and so the question is which one is more. Well, 0.0264 is clearly less than the level of alpha, and so what we say is that this is significant. And because the p-value is less than alpha, the decision is to reject the null hypothesis. Okay. Now step 5 here is we have to write the conclusion, which means to actually answer the question. And so in this case, it says, can we conclude that the temperature has changed since industrialization? Okay, well, let's again review. We rejected the null in favor of the alternative, right? So we think that the alternative is true because we rejected that null hypothesis. So what that's telling us is, yes, there is some sort of change. Okay, so what we write is, using that, there is significant evidence at the 0.05 level of significance to suggest that the temperature has changed since industrialization. Okay, so again, this test dealt with means, and it was also a two-tailed test, so a little different than the one we did with proportions. Okay, but again, the main takeaway here with the two-tailed test is we have to make sure to multiply that probability by 2, and we have to make sure that we take the inequality to be less than. Okay, so this is the only kind of strange one in terms of the tests. Now, if you thumb through the rest of the guided notes, you'll notice there are some other hypotheses tests with the full solutions there, but I wanted to make sure that we worked 2 of them. One was dealt with proportions and was a one-tailed test, and the other, this one being one with means, and it being a two-tailed test. And so the process for these tests are all the same. It's just a matter of determining whether or not you've got a one-tailed or a two-tailed test, and then making sure that you're using the right formulas from Chapter 7, and you got the vocabulary. So this is really tying a lot of concepts that we've looked at so far in the course together, and so I hope that you have found the video to be useful.